was launched in 2014 and is actually a spin-off of Nanogune. And here there is our website if you want to have a look and read more about us. So its very nature is basically implies that we always been collaborating with academia while providing services to industry. So our idea is to bridge the gap that you find between what is developed in academia and what is necessary and industry requires. So our services include, let me use this one. Our services include professional support and training for codes. In particular, Siesta, because it's our flagship code at the moment, but not only. We also have currently ANT and XChem among our codes. We also offer more general material design consultancy for companies, and we also have what we call a code support program in which we help and guide developers, so whoever has a code and wants to develop further the code, distribute it, and eventually release it in the market. Moreover, we are going to launch soon, to release soon our software. I say software, I don't say code. This is, the name of the code is Atomistics Simulation Advanced Platform, ASAP, short form. And I don't say code because it might be misleading, because then you might think, oh, it's going to do what Siesta is doing or Quantum Express is doing. No, it's actually more like a platform that organizes workflows and interact with codes such Siesta at the moment and in the future with other DFT and not only codes. I will give a very short demo after about what we have at the moment. So who we are? This is our core team. We are 8, and this is our Daniel Simon, our CEO. And this is me, and this is Jan Pujol that I mentioned because he's here today and he's going to be here for the next 2 days. So if you have any kind of question or doubt, you can just come to us and ask whatever you want. We are also supported by a board of experts, and among them there is Professor Emilio Artacho and Pablo Ordejon that are here today for this conference. We also have our scientific network of scientists that are willing to help us whenever we need. And, well, I mentioned Nick Papior, Pablo Aguado, and Daniel Sanchez-Portal as they are here today. So, we are also involved in a series of many projects. These are some of those projects. I'm not going through all of them. I like just to mention that these projects are like for innovation and education, and I'd like to say a few words about this Geocta Siesta interfacial tool collaboration. This JSOL is a Japanese company, is our distributor in Japan, indeed, and we developed with them what is called the Siesta interfacial tool. That is a tool that is included in the Geocta, that is the software of the JSOL company. Moreover, we are also involved in the Siesta Pro project, in which we have been collaborating with a group of Daniel Sanchez-Portal, Professor Emilio Artacho, and Javier Junquera to further improve, extend capabilities of Siesta and also Siesta-related material. Let me mention also the Siesta project with which we are collaborating with Professor Pablo Ordejon. Okay, I just move on. If you want to know more, just you can ask later. So our code, ASAP, Atomistic Simulation Advanced Platform. We designed a specific workflow for Siesta, initially only for this, for Siesta. And this basically allows to perform easy and more complex calculation that implies setting up a structure, input file, and eventually launch the calculation and after analyze the results. Moreover, we also thought to develop more specific modules designed to provide specific quantities to analyze specific physical properties. as in elastic bands that I will show later. And this might or might not work with Siesta. It might involve also the need of other codes. And this code, Atomic Simulation Advanced Platform, ASAP, I will show like now in a few seconds as very short demo. However, we will be, during the poster session, we will have a desk where I will be there with Jan Pujol and to answer to all your questions and also to show more about the software if you're interested. Let me also tell you that this code will be released in spring, so we are looking for beta testers, so whoever is interested to become as a beta tester, so to try the code. And we are also looking for developers, so whoever has like things that might be interested, please contact us today or just send us an email. We are actually looking for a developer. Well, I thank you for your attention, although I didn't finish yet because I would like to then move on. And I don't have space for the mouse. Okay. So this is ASAP. I keep it in my hand. This is how it looks like, the main window. Now, here is the idea now of this short demo is just to give you an overview. If you have more questions, please come to our desk. This is the main windows where this is a desktop application. It's going to run, now it's running on Windows, and it's going to run also in Unix systems, such as Linux and Mac. And here is where all the projects are stored. Now there is none, so it's completely white. But now we will populate it. So the first things to do in order to start a new project is to define a structure. These structures can be imported by, if you have already some structure, like in this case, I'm importing a very big molecule. When you start a project, then it disappears different buttons that basically are all the actions that you might perform for this specific project. You can import many different kind of file format. All file format basically supported by ASC, Atomistics Simulation Environment at the moment. We can also create molecules. Here we have some database. These are the one we have available at the moment. I can create a bulk, define the element, kind of lattice representation, and you see, no? Yeah. And here I have my material, my structure created. Interesting, we can also create surfaces before we define as before bulk, and then we cut the bulk. So we can decide to cut it along one particular direction, change the number of layers, vacuum, repetition along X and Y plane. And once we do this, we have our new project with this new material. We can also further view and modify the structure by opening with this is actually the ASC GUI, and you can basically do all the things that you can do in an ASC GUI. So basically, edit the cell, modify atoms, move atoms, substitute atoms, and so on and so forth. So once you define your structure, so you initialize your project, then you can decide the type of project you want to run. In this case, we have these options. There will be more, obviously. So single point calculation, equation of state, geometry optimization, elastic band and vibration. If I, for example, put geometry optimization, then I see that I have also access to these parameters in which I define the algorithm, the tolerance of the forces, and then next step is to define the calculator. Now we can choose between EMT and Siesta. Let's keep Siesta for a moment. And here we have a basic and advanced GUI in order to set up parameters with some parameters that are the default one that are different from the default one of Siesta. Example, I already have we already have some Brilliant zone sampling that is not 111, that is chosen based on the size of the cell. And once we are happy with all that, we can go one step forward and run our calculation. This can be run locally and remotely. In this case, I'll just show you how to run it on locally. And as you saw, I'm running this on Windows. In this specific case, we compile a parallel version of Siesta for Windows, so it will be possible to just click run and perform a calculation in Windows. This is obviously, there are very, like, if you want to run a production calculation, you need to have access to a cluster. But it might be interesting also for education, for example, to have the possibility to run on a Windows machine, on a Windows desktop. Before I created this, I'm not going to run this big surface. So before I created this project, this molecule project, I go and run, and I press run, and it's going to run. And I have my executable of Siesta on my PC, so I just say to this ASAP where it's located, and here I have the output of Siesta. It's going to take just a few seconds. It's a parallel version of Siesta, as I mentioned before, for Windows, and then there is also a widget to analyze the results. In this case, there is not much to analyze, just density of states and energy, depending on the kind of calculation, and there are different quantities that you might want to look at. I'd like to, if I have still time, to say a few words about this net elastic band calculation that you can perform with an ASAP. Net elastic band calculation is a bit more complex, as it requires the definition of initial, final structure, intermediate image, and then optimization of such images. In this case, I'm not going to do all the steps. I'm just loading a project that I said before. So this project is like very imaginative, like .asap extension. And this is the an initial structure that is a platinum atom on a gold surface. And if I do new net project, then I can I start with the initial image, and I can create the final image. You can also import the final image. In this case, I'm just moving one atom from one place to another. Then just save. So in this case, I have initial and final image. I press save. I create another project with sub-projects. So this is going to be initial and final image. Now I did then optimized, did any calculation on a final image, so I cannot really do the interpolation. But if you have this, then you can go here, interpolate neb, and have another sub-project in which you actually perform the neb optimization. So let me load, finally, last thing, project in which I did all these steps. And here I have the whole project, initial, final geometry, and this is the actual neb calculation, where if I go in analyze, I can see the results of this optimization. This is a very simply model. Is just a diffusion of a platinum atom on a surface. This can give you an idea of the potential of this, of all this, of the neb and this interface. Here you see the evolution of these images and the profile of the energy. I also perform a calculation of vibrations, so I can also access vibrations data. So in this case, I have, as you see, an imaginary frequency and two real one. And I can look at those more in detail by accessing the analysis widget of the particular sub-project in which I calculated the vibrations. You can have, let me do this, what density of vibration modes, and also all the vibrations. In this case, just two, but if you have more complex systems, you can do this neb analysis also for studying reactions, for example, between molecules or between a surface and a molecule that dissociate or associate the diffusion of atoms and so forth. So I was going very fast. I was trying to be fast as we don't have much time. I hope it was anyway interesting because you had like an idea of what we do in Simune in terms of our services and also on what we are doing, like in what we are developing as software. We will be, as I said before, in this poster section available for any kind of question that you might have. I think that's all. Thanks for your attention.
So thank you so much, Federico, for supporting the conference and for presenting the company. So now we move to the poster session. So it's in the other building, just in front, in the engineering school. You need to cross the road, and it's just there on the second floor. Okay, just to remember to remove the posters today after the poster session. In principle, we finish at 7:30. The building is emptied at 8:30. So please start removing the one thing. The invited speakers and members of the committee can come by here for one moment. So because we'll use you as judges for the poster.